Picture this. There's a water sensor sitting at the very bottom of a river in rural France. It's been measuring water levels every single hour and sending that data back to a dashboard for 8 straight years without a single battery change or a Wi-Fi connection. How is that even possible? Well, the answer is LoRaWAN. And in this quick explainer, you're going to understand exactly how it pulls off the impossible.
Let's kick things off with the LoRaWAN difference.
First, we got to clear up the biggest confusion out there. LoRa versus LoRaWAN. People use these terms interchangeably all the time, but they are absolutely not the same thing. LoRa, which stands for long range, is just the physical radio technology. It's a very specific way of encoding radio waves using something called Chirp Spread Spectrum modulation. Honestly, just think of LoRa as the bare-bones walkie-talkie hardware. It's the raw, physical language the device is speaking over the air. Now, LoRaWAN is the instruction manual. It's the actual network protocol built right on top of LoRa. It defines the rules, it handles the military-grade security, and it manages how the entire network operates together. And here's the kicker, the range. We're talking up to 15 kilometers in rural areas, and it still easily punches through several kilometers of dense city buildings. It achieves this massive range by transmitting data incredibly slowly, typically just 300 bits per second up to maybe 5 kilobits per second. And that intentional slowness, that's the secret sauce that gives these devices a 10 to 15-year battery life.
All right, let's look at the 3-layer architecture.
The whole system relies on a brilliantly simple star of stars setup. Layer 1, your end devices. These are your field sensors, like temperature probes, water meters, or asset trackers. They transmit tiny packets of data, usually just 12 to 51 bytes. But here's the key. They never talk to each other. That would waste way too much power. Instead, they just broadcast their data straight to any nearby gateway. Which brings us to layer 2, the gateways. Think of these as passive bridges. A basic indoor gateway only costs about $100, but it can cover several floors and a whole city block. If you have a clear line of sight, a single gateway can literally cover hundreds of square kilometers. It just grabs those incoming radio signals and forwards them over standard internet, like Wi-Fi or 4G, serving thousands of devices simultaneously. Finally, we hit layer 3, the network server. This is the cloud brain of the operation. It deduplicates messages because multiple gateways might catch the exact same ping from a sensor, applies strict AES 128 encryption, and securely routes the data to your final application. It is incredibly simple, perfectly scalable, and rock solid. So, how about those device classes? How do these field devices actually stretch a battery out for a decade? They do it using 3 distinct communication classes. Class A is your absolute maximum battery saver. The device sends its data, listens for a split second, and drops right back into a deep sleep. It's like checking your phone just once a day. Perfect for basic sensors. Class B wakes up on a synchronized schedule, kind of like checking your phone every hour. And Class C, it stays awake constantly, listening for instant commands. It's like having your phone screen lit up 24/7, which means it definitely needs to be plugged into a wall. Moving right along to ADR, or Adaptive Data Rate. This is LoRaWAN's genius automatic power optimizer. The network is smart. It tells nearby devices to whisper quickly, which saves their battery and clears up the airwaves for everyone else. But it explicitly instructs devices that are miles away to shout slowly, making absolutely sure they don't drop the connection. The best part? Every single device automatically dials into its optimal setting. You don't have to manually configure a thing. Now let's compare LoRaWAN to the alternatives you might already know. First off, completely banish Wi-Fi from your mind. Wi-Fi is built for heavy, lightning-fast data at a very short range. LoRaWAN is the exact opposite. It's for tiny, slow data sent from miles away. They do completely different jobs. When you stack it up against cellular networks like NB-IoT or proprietary networks like Sigfox, LoRaWAN wins huge on cost and independence. Why? Because it uses unlicensed spectrum. That means absolutely no SIM cards and 0 monthly carrier fees. You can easily deploy your own private network or just hop onto a free community-run public network like the Things Network. Let's bring this into the real world with some actual applications. This unprecedented efficiency is completely changing how we track things. We're talking smart agriculture tracking soil moisture across thousands of acres. Smart cities mapping out trash collection because the bins literally tell the city when they're full. And utilities monitoring millions of remote water meters, all running on batteries that last 10 years. It is without a doubt the dominant protocol for low-power, long-range tracking. It's gotten so huge that Albert Yegan, the CEO of the LoRa Alliance, said they are building the fourth pillar of the wireless communication industry. Right alongside Wi-Fi, Bluetooth, and cellular, LoRaWAN is officially a heavyweight. So, armed with everything in this explainer, here is the ultimate question for you. What impossible system are you going to build with a 15-kilometer range and a battery you don't even have to look at until 2036?